Today we'll talk about selection sort algorithm, which is a simple and efficient sorting algorithm. It starts from the beginning of array and then it repeatedly searches the minimum element. Starts from the beginning of array means it starts from the index 0 location and then it will search the minimum element, that is the element with the least value in the array. It swaps the minimum element with the first element. So it finds the minimum element, and what it will do next is it will swap it with the first element. Then this continues for the entire list by iteration. This will be continued for the entire list till the end of the array. We'll look into the algorithm next of sorting, selection sorting specifically. So in step 1, we'll set min to location 0. To index 0 or location 0. We'll set that value, or we'll set that element to a variable called min. We can use other names as well, but for simplicity we'll be keeping it as min. In step 2, we'll look for the smallest element on the list. The element with the least value, we'll look for the smallest element on the list. Step 3 is we'll replace the value at location min with the smallest element we found in step 2. That is, whatever we find out in step 2, we'll replace that value at the location min. That is the location at the value at location 0 or the value at index 0. We'll replace the value, or we'll swap the value with the smallest element found from step 2. Next, step 4, we'll increase min to point to the next element. So we'll do this to iterate in the list. We'll increase min, initially it was index 0, then we'll point it towards index 1, then to index 2, and this continues till the end of the array. And lastly, which is step 5, we'll continue until the list is sorted. So till the time we find the sorted list, we'll be continuing all the steps. So let's take an example with the array which has the elements 7, 1, 4, 2 and 3 in the order as shown in the screen. So let's look at the picture. So in this picture we see that since there are just 5 elements, to take an easy example, in the first step what we did is we stored 7 in a variable called as min, since 7 is at index 0, and we found out the minimum number in the rest of the array, that is among 1, 4, 2 and 3. So among these numbers we find out that 1 is the minimum number. So we'll swap this 1 with the 7 that was at index 0. So in the first step we see that in the second step we see that 1 and 7 are swapped, and hence since, as discussed earlier, we'll be repeating this process till the length of the list or till the last element of the list. So in the second step, keeping the value 7 in the variable min, we'll look for the minimum number among 4, 2 and 3. So among 4, 2 and 3 we find out that the minimum number is 2. So we'll swap 2 with 7. So in the third element we see that 2 and 7 are swapped, and then we keep 4 and or we store 4 in the variable min, and then we'll search the minimum element among 7 and 3. That turns out to be 3. So in the fourth step we see that 3 and 4 are swapped, and in the fourth step we'll compare who among 7 and 4 is least or minimum. Turns out 4, and so we swap 4 and 7. So at the end we get the sorted list 1, 2, 3, 4, 7. So this is how selection sort works. Next we'll look at the efficiency of the selection sort algorithm. So efficiency of sorting algorithms is measured using 2 parameters. First, time complexity, and second is the space complexity. So since sorting algorithm or selection sorting uses 2 nested loops, first to select an element of array one by one, that is what we were storing in min, we did this for the entire list. So this process takes O(n) time, since we did it for the entire list, and another loop to compare that element with every other array element. the comparison we did is for finding the minimum element. So we'll need to do this comparison with every other element present in the array or in the list. So this process also takes O(n) time. Therefore, the overall time complexity specifically is O(n) times O(n), that is O(n) square. Talking about the space complexity, we see that it takes O of 1 because the only extra memory that we needed is for saving the temporary variables. The first we saved is the array elements one by one. That is, first we saved the index 0 value, second we did is we stored the index 1 value, then index 2 value, and accordingly. And the second variable we had to store is the minimum number in the rest of the array. So we needed just 2 extra variables to store this, to store the 2 values. Therefore, the memory complexity, the space complexity turns out to be just O of 1. Therefore, the time complexity is O(n) square and the space complexity is O of 1. So this is about selection sort.